Hi everyone, this is Mrs. Richart. Today we're going to look at solving quadratics by taking the square root. We have learned to solve quadratics by a few different methods. We've learned to factor by setting the factors equal to 0 and using the zero product property to solve. We have looked at the quadratic formula. And then we've also looked at completing the square. Now we are going to learn how to solve quadratics by taking the square root. Let's recall some inverse operations. We know that the opposite of adding is subtracting. We also know that the opposite of multiplying is dividing. Lastly, the most important for today's lesson is the opposite of squaring is square rooting. These are inverse operations, so they undo each other when you're solving an equation for a variable. We're going to look at how to solve this equation using square roots. For example, if we start with x squared minus 25, I have this squared. To solve for x, we need to undo the square. We can do that by taking the square root. So we're going to go ahead and take the square root of both sides. When we do that, I get x equals positive 5 or negative 5. The reason for that is because if you plug in positive 5, 5 squared is 25. Or if you plug in negative 5 squared is also 25. When you square a positive or a negative, you automatically get a positive. So to write this as our final answer, we say x equals plus or minus 5, and we can use that plus or minus symbol. If you notice, the x squared is by itself on the left side. You can use square roots when you have the terms that look like this. For example, again, we have r squared minus 44 equals 0. The r squared is not by itself yet. So we're going to have to move that negative 44 to the other side. We can do that by adding 44 to both sides. Therefore, we're left with r squared equals 44. Now I have r squared, so I can go ahead and take the square root of both sides to undo that squared. To find out what the square root of 44 is, it's not a nice number like 5. So we're going to use a factor tree. 44, I can break it up into 1 times 44. 1 can't be broken up any farther, but 44 can. So I can break it up into 2 times 22. 2 can't be broken up any farther, but 22 can. To 2 times 11. This is known as prime factorization because the 1, 2, 2, and 11 cannot be broken up into any other factors. When you are looking for squares, perfect squares, you have to have two numbers that multiply together for the same number. So if you notice here, we have 2 and 2. 2 times 2 is a perfect square of 4. Therefore, for our final answer, we can say x equals plus or minus 2. And if you notice, we're left with 1 and 11. So I'm going to have the square root of 11 left over. I can't break that down any further. So our final answer is x equals plus or minus 2 square root of 11. You can also write this as positive 2 square root of 11 or negative 2 square root of 11. If we take a look at this example, the quantity of y plus 5 squared equals 49. I see that whole piece on the left side is squared. I can't subtract the 5 yet because that y plus 5, all of it is squared. It's a single unit. We're going to go ahead and take the square root of both sides. The square and square root cancel. So we have y plus 5 equals, now the square root of 49 could be positive or negative 7. Every time you take a square root, you're going to have a plus and a minus. So we're going to go ahead and break this up into two pieces. Y plus 5 equals positive 7 or y plus 5 equals negative 7. In both instances, we have to subtract 5. So first I'm going to subtract 5 from both sides. 7 minus 5 is 2. So we get y equals 2. For the other piece, we get negative 7 minus 5. We're left with negative 12. So our final answer is y equals 2 or y equals negative 12. Notice we can plug both of these y values in to the original equation. If I plug in a 2, 2 plus 5 is 7. 7 squared is 49, so that is correct. If I plug in a negative 12, I get negative 12 plus 5 is a negative 7. When you square a negative 7, you also get 49, so it works. You can always plug in to check your work. Notice you get 2 answers, and that is really important for solving with square roots. Do not forget your plus or minus. A more complicated example is 2 times the quantity of e minus 1 squared minus 36 equals 0. The first thing we're going to do is add the 36 over to both sides. I want the e minus 1 squared by itself. I can only square root something if I have the square left over. So now we're going to divide by 2. We're left with e minus 1 squared equals 18. Now it's time to square root both sides. When you square root a square, they undo each other. So let's see what the square root of 18 is. We're going to use our factor tree. 18 can be broken up into 2 times 9. 2 can't be broken up any further. 9 can be broken up into 3 and 3. Notice that 3 and 3 will give us that perfect square of 9. So we can pull that out. We are left with e minus 1 equals plus or minus 3, and we have that 2 under the square root that's left over. E minus 1 equals plus or minus 3 square root of 2. When we add 1 over, it is separate from the plus or minus 3 square root of 2. We are left with e equals positive 3 square root of 2 plus 1 on the outside, or e equals negative 3 square root of 2 plus 1 on the outside. Now I encourage you to complete the Solving Quadratics by Square Rooting quiz, and if you have any questions, feel free to email your teacher.